In this video, we want to investigate a little more about the Laplace transformation of an exponential function and on what condition the Laplace transformation exists. So let's say we have an exponential function ft a e to the power alpha t, where alpha is positive. So when we want to find the Laplace transformation of that, it will become like this: 0 to infinity ft e to the power st dt, and this one becomes a e to the power alpha t e to the power minus st dt. So this one becomes 0 to infinity e to the power alpha minus st dt, or this one, after the integration, it will become, so alpha minus s here, and e to the power alpha minus s t infinity and 0. This one we can write a alpha minus s, so basically it is alpha minus s infinity and minus, so let's get rid of the bracket here. This one minus a over alpha minus s, because when t is equal to 0, this is the function becomes like this, the integration becomes like this, and when t is equal to infinity, it becomes like this. Now let's investigate the different situations. So we need to tell here something, that s is actually a complex frequency, so s in fact becomes sigma plus j omega, so it's a complex number. So we can write this like alpha minus s e to the power alpha minus sigma minus j omega, so the real part and the imaginary part, and here alpha minus s. So let's leave it like that, like the complex number in the denominator, but here we want to see what happens when we compare the value of alpha and sigma, basically the real part of the real part of s, and alpha, which is the exponential function's exponential coefficient of t, basically. So when alpha is equal to sigma, this one becomes indeterminate, so the Laplace transformation becomes indeterminate. So that's indeterminate. I'm not writing, I am just leaving it like that. When alpha is greater than s, then of course this part becomes positive here. Alpha is greater than sigma, let's say, so the real part becomes positive. So if we split it down, it will become alpha minus sigma infinity, and then this one will be, so we're just looking at the, so this is j omega, but this one will become a positive exponential, exponential with a positive coefficient, and that will become, when t is becoming infinity, this is e to the power infinity basically, so this is becoming infinity. But when alpha is less than sigma, then this part is negative, the real part becomes negative. So when t is equal to infinity, this is becoming e to the power minus infinity, because the real part is infinity. This part is becoming minus infinity here. So that is vanishing when t is equal to infinity, basically, because 1 over infinity is 0, and this part remains. So this part remains. So our exponential, so the Laplace transformation is basically a s minus alpha, s being the complex number, of course. So that becomes the Laplace transformation. So basically sigma has to be less than the real part of s. That's the condition for the existence of Laplace transformation of an exponential function when alpha is basically the coefficient of t. So this is the condition.